Scooby Data presents you Descry Doctor. Often, we are doubtful of being treated by the best doctor, and here comes the need for a second opinion from someone better. Finding the better nearby to you is a tough task. Now, Scooby Data has a solution for this. Introducing Descry Doctor, the ML model to work on with dataset of doctor's profile that contains fields such as doctor's experience, specialization, achievements, location of the clinic, and based on this, we will ask the user to input certain data fields to predict the best or the better doctor in that location. Obtaining the dataset. The first step was to scrape the data of the doctor's profile from the given link in a README file by web scraping using Python, as no dataset were readily available according to our requirements. Here's a quick look at the code used for web scraping. Now we talk about the dataset obtained from web scraping. The dataset obtained contains 5,526 entries with data fields as name, specialization, city, hospital or clinic address, experience, and awards. Explanation. Importing libraries. Here, we have used pandas for reading the CSV, data cleaning, data manipulation, NumPy and Matplotlib for various mathematical uses. Lastly, sklearn for k-means and min-max scaler. As no dataset is perfect, we need data pre-processing to make our modern-day field perfect. Here, pandas is used for checking for any missing values such as nan and replacing any white spaces with nan. This part counts the nan values in every field. NumPy function drop_na is used for dropping the entries with nan values, as missing data in our case cannot be replaced. Have a look at this dataset as cleaning is done. From sklearn.preprocessing, we have imported min-max scaler to normalize the data of column experience and awards. This line is used for making an award column by assigning values for each award, Padma Vibhushan being ranked highest with 60 points and other awards column being the lowest with 10 points. Now, the scalar.fit transform is used to normalize or standardize the features variables columns of X individually between 0 and 1 before applying any machine learning model. Here we have dropped the individual award section as they are no longer needed for applying the ML model. Have a look at the revised data frame. The scatter plot between experience versus award. It helps us in visualization of our data set. Here we have calculated the sum of squared error and compared it with the number of clusters for the k in range 1 to 9 and appended this in our list. Km.inertia measures how well a dataset was clustered by k-means. It is calculated by measuring the distance between each data point and its centroid, squaring the distance and summing these squares across one cluster. Matplotlib was used for this section to plot the graph between SSE versus K and to determine the optimal number of clusters by the elbow method. In our case, it was K equals to 4. We have divided our dataset in 4 clusters. Km.fit predict. It finds the centroid and assigns the label to the dataset. Here is our dataset with labels. In the final part, where we take input from the user in the following manner: name of the doctor, specialization of the doctor, city of the doctor, experience of the doctor, the award points of the doctor, normalizing the data. In this step, we have normalized the experience and awards data entered by the user. km.predict is used our prediction on our data and storing this in our variable. This part iterates through the dataset and requirements match city, specialization, experience greater than user's doctor, and awards greater than user's doctor. If all these conditions are true, the doctor's profile is appended to the final list. If n is greater than 4, it is an outlier case and we cannot match the data. The final segment prints the best or the better doctor, if any. We'll now be taking few test cases.